Okay, so down to the end. So we've got to integrate this crazy looking function e to the x divided by the square root of 1 minus e to the x squared dx. And I'm looking at this and I'm thinking, all right, this is in my inverse trig section, so I'm probably going to have some type of inverse trig, but I don't really see how it matches up. There's a 1 up here, but this is a function. I do see this square root thing going on here, so I know there's no square root there. I'm okay, get rid of that one. This one's got the square root, but it also has the x, so I got to get rid of that. So somehow I'm going to be using the sine inverse. So I don't know how yet, but I definitely see that I've got a number squared minus a function squared. So maybe I can start with that. Turn this e to the x squared into something squared. Well, what goes in there? Well, this 2x here is kind of like, goes like this here. Remember, a power to a power, I multiply exponent, so that would be e to the x times 2. So that's e to the 2x there going on. So that kind of helps me a little bit. So now I know, what goes inside here. So I can rewrite this. It's integral e to the x over the square root of 1 minus e to the x all squared dx. Okay. So now I'm starting to think, okay, I can't get it to be x by itself like I could up here. Hold on one second. Yeah, there we go. All right. But what I can do is I can make a U substitution with that ugly thing in here. So if I make U equal e to the x, then what do I get? I get the integral of e to the x over square root 1 minus u squared dx. Now, I need the integral to be completely in terms of u. Right now it's got x's and u's. So to fix this, I'm going to find the differential. Du is equal to e to the x dx. And golly, look at that. E to the x dx is right there. So what is this going to be? This is going to be the integral of, I'm going to replace this with du. So it's 1 over square root 1 minus u squared du. Now that looks familiar. That looks exactly what I want here with an a equal to 1. Okay, so now we're cooking with peanut oil. All right. So this is equal to the sine inverse or arc sine of u plus c, where u is equal to e to the x. So this is the sine inverse of e to the x plus c. What a weird function. No wonder it was a weird integrand in here. Okay? So hopefully that kind of gave you an idea. This would be where I have a U substitution. I have to do U substitution in order to solve it. That's why I taught you how to use U substitution in these earlier problems, even though you could have just used your formula to get the shortcut way. You don't have a formula to get the shortcut way here. Okay, so let's try another one. Integral x over x to the 4th plus 9 dx. So, once again, when I look at these options, I don't see any square root. So I kind of can x out this one and x out this one. It only leaves me with this. Well, how do I make it like that? I mean, I definitely see I have like an a of, 9 equals a squared. So that gives me a equal to 9 or 3, right? So, I've kind of got that going for me. But I've got an x to the 4th here, and this is x squared right there. So that's really at odds with what I'm trying to do. So, and then I have this x up top. So it looks like I have a differential of x dx. So maybe I have a u of something 1 power bigger than x. So let's try that. So try u equal to, see, I want to write this in a way that it's squared. So how do I write x to the fourth as something squared? Well, if I put this as x squared in here, then x squared squared, remember power to a power, I multiply, 2 times 2 gives me x to the fourth. So my u now, I'm going to rewrite this. This is integral from x over x squared squared plus 9 dx, right? Okay. So what do I have now? I've got a u equal to x squared, because if I can substitute out, I'll have something squared, right? And so du is 2x dx, the differential. Now, I don't have a 2x up top. I have a x delta x, right? So 1 you can either divide through by 2 on both sides. And so you have x delta x equals 1/2 du, which is perfectly fine to do. So that becomes integral of 1/2 du over u squared plus 9. The other option would be to solve for the dx. So if you went that route, if you had du equals 2x dx and you just said, hey, look, I want to replace this dx with whatever it is, you could just divide through here. And so you see dx equals du over 2x. And so you would take your integral of x over x squared squared plus 9, and I would replace the dx with du over 2x, okay? And so what happens? The x's cancel here, all right? And so you're still left with that 1/2 that comes out front here. All right, so either way, all I'm trying to show you there is either way you do it, you're going to get the same thing. So I'm going to take this 1/2 and pull it out front. So this becomes 1/2 integral of 1 over u squared plus 9 du. Now I still don't have it in the form I want, right? So the form I want it to be is 1 over something squared plus 1, okay? And then whenever I do that, I know that thing is going to integrate, and I'll be able to integrate that thing and its arctangent inverse of the something, okay? So how do I do that? Well, I need to factor a 9 out of both of those. So this is going to be 1/2 integral 1 over 9, and then if I take a 9 out of both of those, what's going to happen? This is going to be u squared over 9 here plus 1 du, okay? And then what does that mean for us? Well, that means I actually need to make this something squared, right? So how do I make that something u squared over 9 equal to something squared? Well, the numerator is easy. The numerator is just u. 9, if I square a number to get 9, okay, if I square 3, I get 9. Holy smokes, what's about to happen? I have to make another substitution in here for this because it's not just u by itself. So what substitution could I make now? Well, the next letter I think of after u is v. So now I'm going to make a v substitution. I'm going to say v equals u over 3, right here. That's what's inside here. And then what does that mean? dv equals 1/3 du, okay? So I want to replace du. I'm going to multiply both sides by 3. And so those cancel. So du equals 3 dv. All right, what a mess. So this is going to be 1/2 the integral of 1 over 9 parentheses, and this gets all replaced, right? What does it get replaced with? Something squared, v squared plus 1. Okay, and then the du gets replaced by 3 dv. Okay, now what do I notice about 3 and 9? 3 and 9 will cancel. So the 3 turns to 1 and the 9 turns to 3. So I have 1/2 times, and I'm going to pull the 1/3 out. 1/3 integral 1 over v squared plus 1 dv. So this is 1/6 integral 1 over v squared plus 1 dv. And I know that the integral here, this integral is equal to 1/6, and then this piece here is the antiderivative arctangent or tangent inverse of v plus c. But what does v equal? V is u over 3. So this is the tangent inverse of u over 3 plus c. But what was the original problem in terms of? The original problem was in terms of x, so I need to go back to x, and lo and behold, u was x squared. So I'm going to replace this u here with x squared over 3 plus c. Bingo, right there. A lot of work, but kind of a cool thing going on. You've got a substitution inside a substitution. Kind of challenging, huh? Maybe a little bit more than what you're used to. Well, you know, this is the end of the course. We're kind of getting into the more challenging stuff in the course right now. Integration is more challenging than taking a derivative, right? One thing to remember is this. I can take the derivative of any function you give me. I can take the derivative. But I cannot find the integral, the closed form integral of any function you give me to integrate. Okay, so every function doesn't necessarily have a closed form of antiderivative. Now, when you take Cal 2, we'll go into more detail on how we can approximate to get as close as we want to that answer. But for now, it's kind of an open question for us. So let's do one more problem. And so I've got the integral from indefinite integral, 1 over x squared minus 4x plus 13 here. Now, this problem takes a technique that you have not done probably since college algebra. This technique is called completing the square. All right, complete the square. And I've got a video that goes way into detail on this in my college algebra link. If you want to go into that and watch the complete the square video, that's great. If you're still needing help completing the square, that's perfectly fine. So here's how we complete the square. So say I have some ax squared plus bx plus c, okay? And I want to complete the square here. Well, what I do first is I make sure my a is equal to 1, okay? For this particular one, the coefficient in front is a 1, so we're good to go. So if your a is not equal to 1, so it was like 3x squared plus 2x minus 7, then to make it equal to 1, what you would do is you divide everything by 3. So I would pull a 3 out, and I'd have x cubed plus 2 over 3x minus 7. I'm sorry, I don't know why I put x cubed, but that should be x squared, okay? And then once a is 1 here, now we can start completing the square on what's inside there, okay? So that's just to show you what to do if a is not 1. But for here, that problem, a is equal to 1. After you get a equal to 1, then what you're going to do is you're going to take the middle term, you're going to take b, and you're going to half it. Okay? You half b. So you do b divided by 2. Okay? Once you half it, then you square it. You half it, you square it. So you b over 2 square it. So let's take this example. Our b here is equal to -4. If I half it, I get -2. If I square it, I get -2 squared gets me 4. Okay? So here's what I do. I have x squared minus 4x plus 13. Okay? I want to complete the square. 4 is my key number here. All right? Because I half it, I square it. That's the number. I'm going to add it in, but I'm also going to subtract it out. Because I want what I'm adding in and subtracting out to not change the original equation or the original expression down here. So when you look at this, these two kind of cancel each other out to make 0, and then you still have your original. So remember whenever I told you all it takes to be a good mathematician is to know how to multiply by a clever 1 and add a clever 0? This is my adding of a clever 0 here, okay? So that's all we're doing when we complete the square. We add a clever 0. So what's going on here? Why did I do what I did? Okay? This 13, and this -4 here, okay? I want to combine those. This 4 here that I found, I want to combine it with this original thing I started with. So I have x squared minus 4x plus 4. And then over here I have the plus 13 and the minus 4. Okay? So this right here, why do we call it complete the square? Because it factors beautifully. This will factor to x, and then whatever my half of my b term was goes in the parentheses. So whenever I half -4, I got -2. So I'm going to put -2 in here, and I square it. Okay, so that's what it factors to. That's what's kind of cool about this technique. And then this adds to, golly, what's that add to? That adds to 9, right? I hope so. Okay. So now I've got to rewrite my integral. It's the integral 1 over x minus 2 squared plus 9 dx. Okay? So I've rewritten it using complete the square. And if this still is kind of tough for you, go to college algebra video on my YouTube page and look up the complete the square video. And I do a lot better job explaining how to do it. This is just a quick basics, a kind of a recap, a review of how you're supposed to do it. So let's handle this. Okay, so what do I want? I want 1 over something squared plus 1. Well, right now, I don't quite have that, do I? Okay, to fix this, I'm going to get rid, that 9 needs to turn into a 1, right? So I'm going to factor a 9 out. Okay, I'm going to try to do this a little bit quicker than I did the last one. If I factor a 9 out of that term, I have a 9 down there. And then plus 1 here. Okay, so what does that mean for us? That means that this is 1 over 9, integral 1 over, now something squared dx. That's what I want, right? Well, how do I make this x minus 2 squared over 9 equal to something squared? Well, the numerator is pretty easy because it's already written kind of as a square, so that's x minus 2 in the numerator. The denominator, if I multiply 3 times 3, I get 9. So what do I put in here? X minus 2 over 3. Okay? Now, I need to make a U substitution. U equals x minus 2. See how I did this all in one swoop? You didn't have to do it all in one swoop like I did here. You could do a U substitution here of U equal x minus 2 and du equals dx. But then you would have to later do a U substitution to handle that 9, or a V substitution to handle that 9. Okay, and so that's where, or rather this, I think, you could try it out yourself if you want to do it the old way of how you did it just a little bit ago. Okay, so if I take the derivative here, well, what does that equal? That's equal to x over 3 minus 2 over 3, right? So du is equal to, what's the derivative of this? That's 1/3. And the derivative of this is 0. So 0 plus 1/3 is 1/3. So 1/3 dx. So if I multiply through by 3, the 3's cancel here. So dx equals 3 du. So this becomes 1 over 9 of u squared plus 1, and then the dx gets replaced by 3 du, and so the 3 comes out front and cancels with that 9, so 3 over 9 makes a third, right? So that's 1/3 integral 1 over u squared plus 1 du, and so what do we get? We get 1/3 tan inverse of u plus c, where u is equal to x minus 2 over 3. Okay? So this concludes your integration and all the different techniques you might run into. This is as hard as it gets, so don't get discouraged. These problems are the bad boys. They're the hard ones, okay? So they're the hardest ones out of what you're going to see as far as integration goes in Calculus 1, all right? So hopefully you've enjoyed this semester. I know it's been interesting, everything that's happened with everything being online, but I hope that we've been able to make the best of this and we can keep moving forward. And hopefully I'll see you again in Calculus 2. I'm really excited. Favorite class to teach. Calculus 1's like the second favorite class to teach. So looking forward to seeing you in the spring.